Welcome to another episode and video on my Raspberry Pi, connected through serial networking and band cable to breadboard and computer. Serially it is connected to Minicom, serial terminal monitor, band cable, as you can see, to the breadboard, networking to VNC, which runs on the laptop. Last time I ended with the unsecure question whether everything actually does work on the analog to digital converter and the analog devices. And mostly the question was about the fischertechnik LDR photoresistor. LDR stands for light dependent resistor. This potmeter did give a slight problem, and I want to find out if that problem still is there. Then I also said that the experiments were actually done by lack of other sensors I could read, so I am expanding the experiment to I2C. And the basic setup is present already: the I2C chip and 3 LEDs. And that's all at this point. Right now I want to see if this still works. So I will start the program and then see if things actually do work. And it looks like they do not as I expected to do. Making better contact with the potmeter, the value gets a bit higher, right, and now the value is as high as it should be. So now I release the pressure on the potmeter, I uncover, I cover it up, and indeed now this whole thing is better. So it is indeed the contact with this potmeter that causes the problem. And that ended last time. So much at this moment for the ADC with SPI interface. Now I2C is totally different. Although, according to my information, it can be directly connected to the Raspberry Pi. And since this is actually the GPIO, I need to find out how exactly to wire it. Well, I have a schematics, but how will it work out? The same question I had with this one, and this is a new experiment. I will leave this one intact for now and see how I can apply it here if possible. So let me start trying to wire and see how it works out. First before I get to setting up this circuit, I want to actually show you the values that the LDR2, the fischertechnik one, works. So pressing the LDR or covering up the LDR2, you see that the value gets quite high now, 194, and uncover it, it gets low again. So this shows that everything works out nicely. And covering up this one, make sure that with LDR1 right above the LDR2 values get low, uncovering, and it gets high. So they have for some reason exactly the opposite working way. Then here, what is going on here? Well, I found schematics. Oh, by the way, I noticed that although I'm running everything, that this is not entirely accurate. Everything is connected, but signals are not coming through for some reason. Anyway, time for I2C, and there is a little bit of a problem. First of all, the problem is already indicated because it's an archive, this page, but they are using a very old version of Raspberry Pi. Is that important? Well, that is not the only thing. Of course, Raspberry Pi model that I'm using can be done, but they're using a very small breadboard, and here they have the power on this side, power and ground. Whereas if you look at my schematics, this is a single power line. So I will have to bridge everything there. It will have to go over it, and that is not making things easier, because look here, this is ground, this is power, and 1, 2, 3, 4 to the ground, 1 to the power, here is 1 to the power, and then a few to LEDs, which I have put a 3 on the breadboard as well, although without resistor yet. And then I have to wire it from the I2C chip to the LEDs, and then of course to the board. So wiring is going to be a bit of a challenge, and since this is the direction, usually it is now 1, 2, 3, 4, so it's 3, 4, 5 and 8 that I have to wire to the ground. And then the question, how to do that nicely? Well, I'm not quite sure yet. Making jump wires has to be. So let's try. Right, a number of wires added. First of all, 3 resistors, which are not exactly the same value as in the example, but I don't care. I'll see what goes on and how it will go. Then I had to put a few ports to ground. So I don't know how clear it can be seen, but little jump wire to connect to one, and then a big jump wire here. So these 3 here are now connected to ground. This one had to connect to ground, and everything with one large to ground. So they're all grounded. Then one band jump wire here to the power, and one jump wire here to the power. And now I'm making a mistake, I see, because yes, this one is not good. This one is too small, unfortunately. How can I improve? Well, just one ordinary staple, which hopefully is long enough. Yes, it is. And by lack of real jump wires, I again have to rely on a staple. Will this work out? No clue, we'll see. Then 3 jump wires, this one to the resistors, and then most importantly to the GPIO. And it's clock and data. I2C only needs 2 wires, and they go here. Will this suffice? Will this be okay? Right now I have just put the hardware together, and I will have to see. I'll just have to see how this works out, if it works out. Because next step is of course the software. Wiring up is nice, but without the software it won't do a thing, and that is exactly the same as I have seen here. One major difference: this will be in C as far as I can see it now. This is Python. Can they run together? I suppose so. We'll be curious if it does, but that will be a nice experiment as well. Will everything run as intended? Another thing is, and for that, this is something I didn't foresee. The oscilloscope cannot measure SPI and I2C at the same time. So in order to measure this, I will have to let go of this. Anyway, these are the first steps. Now on to the next. Adding some more curiosity and excitement. So let's take a look. And then you find out that, oops, where has the VNC gone? Well, very simple put, it's gone. The Raspberry Pi has reset itself. So I have to start all over. And usually I don't show this, but who cares for now. I have to reset the VNC server for 2466 process. Alright, now start the VNC server with correct screen parameters, otherwise I get a very small screen. And now I will get the good screen, and yep, and that's it. Resize so I can get nice, very nice screen. Now I'm about to automatically open idle for Python, but this is not intended for Python, this whole thing. So that's going to be new. Let me put this one here. And what next? Well, this is still on SPI because of the ADC, which is SPI protocol. So, like I said, I'll have to redo it. Also, I have to add it here. I already added some things here. Do I have I2C? Not really. No, I can find. This is an ADC, so I will have to find something in the line of this. Maybe, who knows. And this goes on and on. I think I will have to do it somehow in another way. Also LEDs. One, 2, and 3. Then also resistors. I don't have a resistor here, not the ordinary one anyway. 4. Although, maybe, just maybe, I should start another schematics, because this is on the ADC and this is on the I2C. Okay, that's later. Let me stop with this right now and make sure that I get the software running. And the software, I have to use wget and then some software, and this is the chip I'm using. How will this work out? Because it's old, I'm very curious if this will download anyway. I am going to copy this. Then here, will this copy? Paste? No. Okay. So this will be a manual copy. skpang.co.uk. Okay, and then slash what? DL and MCP. Okay, DL MCP 23.8.tar, I think. Yep, tar. Now let's see whatever happens. Well, it did, no doubt. Here it is. So, despite being an archive, it's still there. And then, yes. There we are. RaspberryPi I2C. And more instructions. Start the example by. The example is then based on 8 LEDs. I have only 3. Who knows? We'll see. Underscore demo. And now I'm curious what will happen here with 1, 2, 3 LEDs. Start. Oh, sudo demo. Okay. But it does run anyway, and if I use sudo, not doing a thing either. To compile the program, make all. Okay, well, this is not working visually anyway, so I will have to change the program. And see whatever is in it. But with new experiments, you never know how it goes. Alright, this is the program, the demo program, and the question is, does it even compile on my system, because I have here an included I haven't seen before. So what I will do is I will change the delay a little bit from 2 to 300. It is an infinite while loop, while true. Well, set all pins for output, alright, and write to plot, small delay, and then apparently the idea is that you have a walking LED array, starting, etc. So, at least that is my idea that I get from this piece of software right now. So let's write it, and then I have to, according to the instructions, make all. That is not that hard. I just have to go to the directory here, say make all. No errors, quite important. Demo. Start. What will happen, if anything at all? If it starts from the other side that I haven't wired yet, then I could be too impatient and that it goes from somewhere here to slowly here. But then 300 and 200 are very small numbers. Very small, so that could be a real fast walking light, and in that case this doesn't work. So let me look here. Well, this is looking to 144, so it's a very small resistance. If if I read it right, and the resistors I use are 8 something, so that may be a lot more, maybe too much, and that it indeed doesn't do a thing. Not quite sure. All I know is this doesn't work at the moment. So let's interrupt. How can I go on? Well, for now getting a better idea on schematics anyway. So let me add a resistor. Well, this one, European. And then I should need some wiring. That's not for this one. No other resistors in place, so this is R1, R2 and R3. With the wiring. And then they are coming from several ports, but going to... Oh, is that something that I missed? No, because that is just ground. So they are going to nowhere, they are just being addressed. That means that this can just as well be connected here. Ah, and that doesn't happen, so I have to wire them. Each one individually. And then somehow from an IC that I don't have put in yet, to clock and data. How will that go on? I think that's for later. We can try to find just some elements. I don't. No, I thought maybe if I type in the element then it will get it, but it doesn't. And this being quite generic, nope. Don't even know what brand it is. Anyway, I'll have to make up for something. And remains, yeah, what? Maybe I should find some more LEDs to get the whole array of 8 complete. I'm not sure yet. All I know is this doesn't work yet. Last segment of this episode, with the schematics drawn not complete, probably the setup not complete, most likely even, the wiring hopefully correct, programmed in C, which is of course very different than the repeating stuff of Python on the ADC with SPI. And how will this go? Not sure yet. I have done quite some time before setting up this, getting it to work, understanding it. How will this go? We'll see. For now, thank you for watching. If you like this video, then please subscribe to my channel if you haven't done so. Also, you can follow me on Twitter, retweet and like, leave a comment. You can also follow me on Instagram. Please like and leave a comment. I always respond. Please donate to keep videos coming to you. Much appreciated. You can also become a patron and have your name mentioned depending on your pledge, either just on my website or on my website and with the videos in some way. More information on my website. And this is of course going to be continued. So let me run for the last time the changed thing for this. I still see no walking LEDs. Well, you will get what I mean with that. And I hope that this chip is not ruined. Anything can happen. Anyway, that's it. Bye bye.